Gradeup channel of YouTube. So all of you please join together. We'll start solving problems related to combined stress. कल बात करें. Hello Priyanshu. Am I audible to all of you? I hope I'm audible to all of you. Please join together quickly. Join quickly so that we can start our session. We'll be solving some fantastic questions here. Please let me know whether I'm audible or not. Okay. So this is Gradeup Gate 2022 Civil, a free crash course, that is Civil, the champion study plan. To get the maximum benefit, go to the description box, and in the description box you'll find the links, different link. There is a link for the schedule, and if you'll go in the schedule link, you'll find that notes and link for the classes, everything will be there. Everything will be there, right? So get the maximum benefit. Those who are aspirants of GATE 2022 will get the maximum benefit in that aspect. Let us start now. All of you please share. And yes, good evening and happy Raksha Bandhan to each and everyone. Hello Samrita. Happy Raksha Bandhan to all of you. So this is my small introduction. You can always join me on Civil by Ansari Sir in the Telegram channel and ask any of your doubt. There is a batch going on for Vision 2022 for GATE and ES, both Hindi and English. You can subscribe. These are the star faculty of the Gradeup, and there is a flat discount going on, that is 50%. Use the code word RAKHI Rakhi 50 and you will get the subscription for 50% off. The one which I was explaining, and today also you are just studying here. This is a practice session we are doing in YouTube. Already theoretical portions are going on in Gradeup app at 11 AM. So theory plus practice along with the notes, everything you will be getting there. So that is why I am saying that you go to the description box, go to the schedule, and there you will find for each and every subject, each and every chapter, you have a notes, you have a practice questions, everything will be there. A link will be provided there. There is an exam for BAR 2021, that is mega mock challenge on 29th August. Now start the question. There is a question here. The first question in front of you. All of you please share and like and just start doing this one. A solid shaft of 100 mm dia is subjected to tensile stress and torque tensile stress and torque as 20 Newton per mm square and 10 pi kilo Newton meter. The maximum shear stress induced in the shaft approximately. What will be the maximum shear stress induced in the shaft? This is a question of combined stress, isn't it? What will be the answer? Can you solve this one? Can you solve this one? So here if you'll see, torque is given. He's asking about the maximum shear stress, right? A solid shaft of 100 mm dia is subjected to tensile and a torque. So you have a solid shaft which is subjected to both a torque as well as as well as a tensile stress, isn't it? So the tensile stress subjected is nothing but 20 Newton per mm square and a torque of 10 pi kilonewton meter. Torque of 10 pi kilonewton meter. Now if you'll take an element here, you'll find that the tensile stress will be produced, will be creating the stress here, a tensile stress, and torque will be creating the shear, isn't it? The torque will be creating the shear all around the element. Now this is the state of stress of the element. Just you take that element out and you'll find that this element is subjected to tensile stress and a shear stress. That's all. Now here tensile stress is given as 20 Newton per mm square and a torque will produce that shear stress which we need to calculate. How you can calculate? The shear stress due to the torque will be 16t pi d cube. 16t pi d cube, isn't it? Now solve this one. 16 into torque value is given here, that is 10 pi kilonewton. You please change it to Newton, that is 10 raised to 3, and the meter also if you change it will be 10 raised to 3 once again. Make sure it will be in mm. Then pi and dia is given as 100. So 100 cube means 10 raised to 3 to power 9, that will become 9, isn't it? So finally how much you'll get it? 9 pi will get cancelled and you'll get any mistake. This is 16 t 10 pi kilonewton has been Newton, meter has been changed to mm, and okay, sorry, this 10 square into 6, 10 raised to 6, this will get cancelled. 160 Newton per mm square, you will get the shear. So now you got the shear stress value, that is 160, and already you have a tensile stress, already you have a tensile stress. How much you're getting it? Okay, that's great. So if you calculate here, the maximum shear stress has been asked. You know that what is the value of max? How will you get the maximum? This is the state of stress, right? For that, the maximum shear stress will become how much? Simply under root of sigma x minus sigma y by 2 whole square and plus tau xy square. Now instead of asking maximum shear stress, the same question I can ask you by asking that, can you tell me what will be the radius of the Mohr circle? This is nothing but the radius of the Mohr circle. This tau max is nothing but your radius of the Mohr circle. Agree, no? Radius of Mohr circle. So one can ask in that way also. If you calculate, see here, it is 160 Newton per mm square, your tau value, and the 20 is your sigma x value, sigma y is 0, so it will become 10 square plus 160 square. So approximately it will be somewhere more than 162 or maybe something like that. So it is approximately nearby 160 once again, isn't it? It is approximately nearby 160 once again. So that will be, why not? That principal stress only we are using. What else we are using, Harish? Absolutely we are using the same one, right? So combined stresses are means what? Now can you solve this one? Bending moment M and torque is applied on the solid circular shaft. If the maximum bending stress equal to maximum shear stress developed, then M is equal to a very easy question. This is very easy question. Can you do this one? Can you do this one? What will be the value here? Okay, so you know that bending moment M and a torque both is applied on the solid circular shaft. The maximum bending stress equal to maximum shear stress. See, maximum bending stress individually produces 32 M by pi d cube. That is the maximum bending stress will be produced, and the maximum shear stress will be produced nothing but equals to 16 T by pi d cube. That's all. If you will equate these two, the maximum bending stress and maximum shear stress produced by the torque, what you are getting it here, M will be equals to what he's asking. Yeah, he's asking what is the value of M. That will become simply T by 2. That's all. That's all. What what is the answer for this one? What will be the answer for this one? The equivalent bending moment under combined action of bending moment M and a torque T. If torque T and M both have a combined action, if you have a combined action, so here you have a shaft which is subjected to bending as well as torsion, bending as well as torsion. So due to the bending, if you'll take the element here, it will be having tensile stress. If I'm taking the top element I'm talking about, right, a bending is doing in such a way that top one is under tension and bottom one is under compression. So I'm just considering the top one. So there will be a shear and a stress like this, right? This is the state of stress here. Now for the state of stress, what will be the maximum? See, this is the relationship. Actually I suggest that it will be better if you can remember, but one can do the derivation for that. Maybe I hope you all of you have done that already, isn't it? If you'll do the derivation, that is also quite easy. How will do that? Have you done this one? So equivalent one, no, right? Equivalent one. If you see here, equivalent, how to do this one? See, you just take that state of stress, right? This is the state of stress, and find out what is the, you have already that maximum bending stress, and you have here shear stress due to the torsion. So maximum bending stress you already know, that is sigma b is nothing but 32 m by pi d cube, and the tau value already you know, that is 16t by pi d cube. Now using that, find out what is the maximum, what is the principal stress sigma 1 by using the formula of principal stress. If you'll find out the sigma 1, simply you will end up with 16 by pi d cube and m plus under root of m square plus t square. Now this is the principal stress. Principal stress means the normal stress which is maximum at anywhere in this plane. Now the equivalent concept is what? He's asking what the equivalent bending moment means. If the equivalent bending moment, okay, equivalent bending moment, it means if instead of combined torque and bending, if I will apply only bending, it will produce the same amount. So what does it mean? Just equate these two, 16 by pi d cube, 16 by pi d cube m plus under root of m square plus t square must be equals to 32 if single moment is only applied, not the torque. It will produce the same amount of bending, which is a 10 bending stress, 32 m by, that is m equivalent by pi d cube, and here you get m equivalent equals to what? Simply 1 by 2 of m plus under root m square plus t square. Are you getting it? If you have any doubt, please ask me. Did you get that? So here, this one, how you are getting it? This is the state of stress you have. By using that, this state of stress, calculate the principal stress. You already know that principal stress formula, right? I hope already you know that the principal stress formula, right? Sigma x plus sigma y by 2, isn't it? Then plus under root of sigma x minus sigma y by 2 whole square, then plus tau x by whole square. Now here you don't have sigma y, right? Only you have sigma x, and instead of sigma x you put the value of sigma b, and here tau value you put it here, and finally you'll get the principal stress like this. That is the maximum tensile or normal stress produced by combined torsion and bending. Now same stress, if it can produce by only bending, equate these two, that's all, and you'll get the equivalent bending moment. Did you get that? Now can you solve this one? A member is subjected to combined action. Today actually my mobile got switched off. I have to read the comments here only. Don't drive. Someone is saying do not drive. Someone is saying drive, please. Okay. So a member is subjected to combined action of bending moment 400 Newton meter and a torque of 300 Newton meter. what respectively are the equivalent bending moment and equivalent torque. Now if you can remember the formula, then only you will be able to do that. So here I'm not going to derive it. So equivalent bending moment, what is the formula? Just now you have seen it, isn't it? M plus under root of m square plus t square, isn't it? And what is the equivalent torque you have? Equivalent torque, what is the equivalent torque you have? Just yes, under root of, only you have to leave this part. If you have, see, that also can be derived, no? I'm not going to drive that once again. Don't worry, don't worry. A lot of people, they don't. Okay, so now just put the values here, and the member is subjected to combined action of bending moment and as a torque. So what is the equivalent bending moment? Put the values here, how much you will be getting. M equivalent will become 1 by 2 of bending moment is 400, 400 plus under root of 400 square, and plus torque is given as 300 square. So 4 9 तो 25 25 5 5 9 450 हो गया 450. That 450 is the only one option. I hope the other one also you put, you will get 500 only, right? It is the 500. A solid circular shaft of diameter 250 mm is transmitting a power of 2 megawatt at a speed of 140 rpm. It is subjected to a bending moment of 25 kilonewton meter. Determine the equivalent bending moment and maximum principal stress. Yes, here you need to apply some. Now can you solve this one? Can you solve this one? Here you need to calculate equivalent bending moment as well as maximum principal stress. Easy to calculate. First of all, see, a solid circular shaft of diameter 250 mm is transmitted power of 2 megawatt at a speed of 140 rpm. It is subjected to bending moment 25 kilonewton meter. So bending moment is directly given. That's 25 kilonewton meter, right? And torque value has not been given directly. What you'll do here? You need to calculate the torque value, isn't it? So calculate the torque value. What will be the torque value here? A power has been given. So it is actually a mixture of torsion and bending. Once again, if you calculate the torque, simply you can apply 2 pi n t by 60. That power has been given. So sorry, power equals to 2 pi n t by 60. From here you can find out the torque value. The torque will become power into 60 by 2 pi and n. Now put the value here, that is 2 megawatt. Okay, take care of the megawatt. It will become 10 power 6 to make it watt. And 60 divided by 2 pi, correct? No, then what else? N, number of revolution per minute, is given 140. If you calculate how much you are getting it, if you calculate how much you are getting it here, can you do that? You'll get almost 136.42 kilonewton meter. Once again, I'm just converting it into the kilonewton. 136.42 kilonewton meter. Now once you got the moment and torque, a combined equivalent one, how you calculate? The same one, no? 1 by 2 of, what is that? M plus under root of m square plus t square, isn't it? Now m is already given, that is 25, and under root of that 25 square, then plus 136.42 square, and outside you have 1 by 2. How much is the M equivalent you are getting it now? The M equivalent you will be getting it almost around 81.85. Now once you are able to find the M equivalent value, what you'll do here? See, if the maximum principal stress is asked here, what is the appropriate way to see? Either you use the state of stress, either you use the but instead of that you can do, see, already M equivalent already you have. So sigma maximum you calculate, that will produce, no? Because the equivalent moment is going to produce the same amount of the principal stress, isn't it? So instead of using once again the diagram, then moment and torque, but then the state of stress, actually you have already the M equivalent. Use the M equivalent, that is 32 M equivalent by pi d cube. It will give you the maximum principal stress. Agree or not? Agree or not? So use that one, 32 M equivalent, that is 81.85 divided by pi d cube. Div is already given, 250 cube, right? Just a second. Dia, if it is 250, then you need to change it to meter, right? Dia is 250 now. Please change it to in meter. Yeah, please change it. Maybe 0.25. Can you calculate this one? How much you are getting it? Everything is meter, so change that one also in meter. How much you'll be getting it here? Please calculate this one. I hope you will be getting it around, see, because this is only matching, no? You will be getting it around 53.36. So just calculate this one. So once you will calculate the equivalent one, then calculating maximum is always easy. Even if the people will ask you what is the maximum shear stress, and already if you have calculated the T equivalent, it is I will say that, suppose if you have already calculated T equivalent, then just calculate the maximum shear by using 16 T equivalent by pi d cube. That's all. Now, a hollow circular column of internal dia D and an external dia 1.5 D is subjected to compressive load. The maximum distance of the point of application of load from the center for no tension. What will be that one? What will be that one? No comments. What will be the answer here? So now, if hollow circular column, okay, the hollow circular column, he's asking that where I should apply the load in such a way that that's the eccentricity he's asking, right? The maximum distance of point of application of the load. So if this is your hollow circular column, if you'll apply the load at center, you are not going to produce any tension in any side of the fiber, right? But if you will shift the load by some amount, yes, it is going to produce the tension in this fiber, in this zone, right? In this fiber it will be compression only. Now he's saying that nowhere you want a tension. What does it mean? Suppose here you are producing a load that by amount E, you are shifting your load P, and PA will be P into E will be produced here. That is the load which will be on your column. Now that P will be producing a compressive load, that is simply P by area will give you the compressive load in this particular surface, and the PE is the moment which will provide the tension on the surface, which is nothing but your due to the bending stress, isn't it? Now due to the bending stress, what will be your tension? So that is nothing but my by I, isn't it? So my by I, if you see, that is PE into the y, that is maximum fiber distance, maximum fiber distance, or let me write down by I. That's all. It must be equal to 0. So do that here. So P is how much? Not given. Okay, P divided by, and PP just take common, no need to carry over here, right? PP take a common and it will go away. So or should I write down once at least? Then area is what? Area is pi d outer. D outer is how much? That is 1.5 d. 1.5 d square. Okay, pi also will get cancelled, but okay, I'll write down at least pi d square minus d outer square, d inner square, right, by 4 then minus of P into E multiplied by the outer fiber distance, that is nothing but 0.75 of D. The outer dia is D, so half of that, divided by I, that is pi d4 by 64, 64, and d4, that is d outer, 1.5 d4 minus d raised to 4 equal to 0, equal to 0. Did you get that? Now if you solve this one, see, pi by 4 will get cancelled, pp will get cancelled. Simplify this, and you will end with the e equals to 13d by 48. Simplify this one and you will end this. Actually you will end with something, maybe this is something, maybe I got it, it is 3.25 d by 12. Then you have to justify which one is matching here. After solving, actually, let me write down. Just if you simplify, no, you will get 3.25 d by 12. Multiply by 4 at top and bottom, and you will get that 13 d by 48. Did you get that? Do you have any doubt here? Is it clear? Now, what about this one? A solid circular shaft of diameter 20 mm is fixed at one end and loaded at free end. The way it has been shown here, by torsion of T, produces a shear of 50 megapascal. A transverse load of 1 kilonewton and a compressive load of 10 kilonewton. So all the three are applied together. That is bending, compression, and torsion. Length of the shaft is given. What will be the principal stress on element B as shown in figure? Can you do that? Can you do this? To get the maximum principal stress, what actually will go inside your head? First of all, what will be your approach? The approach will be, due to all the loads on the element which is at B, what is the state of stress? Once you will understand what is the state of stress, it will be easy for you to calculate the maximum principal stress, isn't it? Simply you have to apply the formula. So first of all, you need to identify all the state of stress which is going to act on the element B. Agree or not? All the state of stress which is going to act on the element B, first of all, that you need to calculate. Agree? Now, due to the 1 kilonewton, you will be having a bending moment here at B. If you see the section, if you consider the section here, the bending moment here will be what? That is 1 into what will be the bending moment. So I'll just simply write down the directly bending stress here. So bending stress at B will be nothing but 32 m by pi d cube, and here you will get 32 and m. What is the m value here? M value, if you see here, 1 kilonewton, I will multiply with 10, multiply with 1000, so that it will be in a newton. So 1 into 1000, and it is 100 mm, so multiply by 100 also. Okay, that will give you load multiplied by distance, isn't it? 1000 into 100, then divided by pi d cube. Pi and dia is given as 20 mm. Okay, pi d cube. How much will be getting the bending stress? The bending stress you will be getting around 127.23 Newton per mm square, right? Now, how much torsion the torque is producing directly, it has been given as 50 MPa. That's good. And what the 10 kilonewton will be doing here? That's see, the 10 kilonewton will be producing a compressive stress. Calculate that compressive stress also. Calculate that compressive area. First of all, area of the shaft will be pi d square by 4, isn't it? Pi d square by 4. If you calculate, that will become pi, and d is 20 square by 4. How much you will be getting it here? You will be getting around 314 mm square. Now, what is the compressive stress? So compressive stress produced will be 10 into 1000, that is Newton, divided by 314. And how much you are getting it here? How much you are getting it? The compressive one, you are getting it 31.85, 31.85 Newton per mm square, right? Now, the state of stress, if you see, the state of stress on element B, you have a tensile one due to the bending. You have a compressive one directly applied here. So finally you will be having a tension that is nothing but 127.23 minus 31.85, isn't it? Which will be coming around how much? How much you'll be getting it here? Around 95.47. Can you just calculate this one? 0.78, I don't know. You'll be getting it around this much. So that is the tensile stress, and the shear produced due to the torque, that also you have calculated. That you have not calculated yet. Oh, that is given already. That is 50 MPa has been produced by the torque, right? So that also you have, that is 50 Newton per mm square. That is also in Newton per mm square. Now to get the maximum principal stress, you need to simply apply your formula, that is sigma 1 is how much? What is the value? That is sigma 1. If you calculate, that is sigma x plus sigma y by 2, sigma x plus sigma y by 2, then what? Plus under root of sigma x minus sigma y by 2 whole square, then plus tau xy square, isn't it? Just put all the values here. You do not have a sigma y, so sigma y, let it be 0. You do not have sigma y, it will be 0 here, it will be 0 here. Put the values, that is sigma x already 95.47 and tau value 50 square. You put it all the values here, and sigma 1 you'll be getting around 116.919 Newton per mm square. So if you know what is the approach, if you know how to do the problems, it will be easier for you to calculate, right? It will be easier for you to calculate. It is not, see, it is only the calculative. It is not tough. Once you know that due to all the loading, what will be the state of stress at a given point, then you can calculate very easily. Is it clear? Okay, all options are same. I'm sorry. All options are same. Sorry. So did you get that? Please let me know if you have any doubt here. Now can you solve this one? How to solve this type of problem? The maximum tensile stress at the section XX as shown in figure. What will do here? Maximum tensile stress at the section XX. So just draw this diagram separately. Now the line of action of the force, if you see here, it is acting at this location, isn't it? Now at this section, if he's asking what is the maximum tensile stress, so this load, the P, will be producing here. If you just shift at the center of this element, shift it, so it will produce P, and bending of P into this distance is what? This distance is d by 4. So P d by 4, that is the bending produced if you will shift the load here at this point. Now just calculate at this section what is the stress, maximum tensile. So maximum tensile will be at this location, right? So maximum tensile stress will be directly P by A. What is the area here? Area of this section is nothing but this section has area. Suppose some B is the width, B is the constant width it has, and the depth it has a d by 2, isn't it? If you see here, depth it has a d by 2 only, and width is B. Everywhere it is a width B. It has a width B, right? Now P by A, and plus this moment also will produce the tensile stress, which is nothing but My by I. So just solve this one. What is that P value here? P divided, sorry, area is what? That is B into D by 2. B into D by 2. Then what? Plus, what is the moment? That's P D by 4. What is the fiber distance from here? So the fiber distance is D by 4 once again. Divided by I. What is B dq by 12? What is B? B is B. And or I can write down that, M, that is P D by 4. You can write down like that also. BD square by 6 also you can write it down. That's Z value directly. Now B dq by 12, so B and D is D by 2, so dq by 12. B dq, D is already D by 2, I'm sorry. D is already D by 2, so D by 2, dq by D by 2. B dq by 12. By 12 will go at upper side. Now simplify this one. It will be 2p by bd and plus, how much you'll be getting it here? Can you just solve this one? D square will get cancelled. 12 tintia no, 27. How much you'll be getting it here? 12. Just a moment. 12. 4 12, 3 by 4. Just a second. Once again, by 4 into that 3 into 3 into 3 will go at the top. No, it was D by 2, sorry. So 2 into 2 into 2. 2, that is 8. 8. Then you have a P D square by B dq. And it will become kitna? 4 2 is 8. 4 3 is 12. It will become 6. 6. So 2p by bd plus 6p by bd, and it will become 8p by bd. That's all. 8p by bd. That is all about. So combined stress problems you will be getting around. Either it will be due to torsion, bending, axial, all together. That is all about combined stress. Now if you have any doubt, please let me know. Please ask me if you have any doubt here. Samrita, Vinoy, Babu. So once again, happy Raksha Bandhan to all of you. Tomorrow we'll meet once again at 6:30 p.m. Do not miss the session. Quickly we will solve fantastic problems. We'll see that how whatever you are studying in your, whatever the concepts you are studying around, how to implement it, how to solve any of the problems, right? I hope all of you have enjoyed today. That's all from my side. Anything else if you have to ask, please ask me. If anything you want to ask. How to decide the direction of shear stress? Okay, Vinoy. Related to that, I'll bring one problem. Someone asked me in the telegram that I have covered maybe day before yesterday or in some of the classes, right? When bending moment is acting. Okay. When bending moment is acting, how to decide the shear stress direction? I hope I'll be covering in some of the questions. Through the question, I'll cover your question. So that more explanations you'll get it. Anything else? Torsion perpendicular to the plane. Torsion perpendicular to the plane. No, I didn't get that. What you are trying to ask? Is it doubt? Practice problems. Do not take much tension. Efficiently, you just practice the problems and do not take much tension. Whatever you have studied, that's enough. Have a confidence. Have a confidence. So that's all for today. We'll meet once again tomorrow with some fantastic questions. There's a Gradeup Super subscription which will provide you all the structured live course and green card together. That's all for today, and once again happy Raksha Bandhan to all of you. Please take care. We'll meet tomorrow once again at same time, that is at 6:30 p.m., isn't it? Take care. Good night.